Hello students, how are you all? Hope you all are doing well. So today the topic of discussion is regular falsi method. This topic comes under unit 2. Previously we have completed bisection method and Newton-Raphson method from this unit 2, and now today we are going to study regular falsi method. So basically in this video we will going to learn what is the formula of this method, how the formula introduced, and what is the working scheme, and how the most important thing, the how we will solve the numerical problems regarding this particular method. So let us start with the first of all the introduction to this formula and about this geometrical interpretations of the regular falsi method. Suppose this is a two dimension. We have a function. Suppose we have a particular function this type. This is a function y equals to f of x. This function is y equals to f of x. Now students, just remember one thing in that whenever a curve cuts the x-axis, at which this point the curve cut the x-axis, this particular point is nothing but this is your function f of x equals to 0. Now this means that we have found a particular value of x. We have found a particular value of x. For this the function value gives 0. Okay, so the curve cutting the x-axis at that particular point, that is the root, that is the required root. We can say the alpha is the required root. So now back to the discussion of the geometrical interpretation. So suppose this is a curve and a curve cutting the x-axis at the point alpha, and alpha is the required root. We have to find that required root by using this regular falsi method. Now how to do that? First of all, we will find a function or we can find a point at which the function gives the negative value, and again we will find another point at which the function gives the positive value, because previously we have learned that first of all, for the question if y equals to f of x is given to you, first of all we have to find f of a and we have to find f of b. We have to find these two things in this particular manner, that f of a into f of b is less than 0. Then we can conclude that the root lies between a and b. This thing we have start studying from the bisection method, between a and b. So for that, first of all we have to find an f of a and f of b. So here we find a point a, this point a, for which the function value is negative. That's why we are drawing the line downwards to the x-axis. That's why the negative. So we name this as a point, and a point coordinate is like that. A is the x-axis distance and the function value f of a. And again we will find another point b for which the function gives the positive value. Suppose this is the point b, this is the point b for which the function gives positive value, b f of b. B is the point on the x-axis and f of b is the function value. And by the theorem, if f of a has negative value, f of b has positive value, that means what is that? F of a has negative value, or what we can say, f of a has negative value, f of b has positive value, then f of a into f of b will be less than 0, and which implies the root lies between a and b. So there's, in this particular way we have assumed this 2 point AB. Now what we will do, this is a curve, this is the point A, this point B. Let us name this point as D. Let us name this point as D. Now we'll draw a chord joining this 2 point A and B. Okay, let us try to draw a chord which is joining this 2 point A and B. So we have drawn that. So this is a chord AB which joins this 2 point A and B, and which cuts the x-axis at the point C. We name this point as C. Now what is the coordinate of this point? Since this point coordinate, let us assume that this point coordinate is as x, this distance from, this is origin, from origin to C the distance would be x, let us assume that, and this, for this point the coordinate of y will be 0 because there is no peak for y, so that's y coordinate, y value will be 0. So this is all about the pictorial. Okay, now what we'll do, we will find the slope. Slope of whom? Slope of this line AB. Now we can see that A to B is a line. On that particular line C is a point. So that means C, the point, is also lying on the point line AB. So what we'll use here, we'll use here the slope of AB. That means this full line slope will be equals to slope of line AC. AC is the line which is a part of the line AB. Now first of all, a short revision of the formula of slope. Now slope formula, just remember that if I'm writing slope between 2 points, say x1 y1 and x2 y2. So what is the formula of the slope? Slope is, remember the formula, y2 minus y1 by x2 minus x1. Remember this formula. Slope formula, y2 minus y1 by x2 minus x1. So we will use this particular formula here to find the slope of AB and slope of AC. Okay, so let's start. So slope of AB. Okay, now what is the AB point? A point is this. That means we can say that x1 this is, and this one is y1, and B point, that is, we can say this is x2 and this is our y2. Now by using that formula, y2 minus y1, y2 minus y1, so that is f of b y2, that is our y2, y1 is f of a y1, then x2 divided by x2 by x1, x2 is our b and x1 is our a, that means b minus a. And this side, okay, this one finished. Now slope of AC. AC means A point and C point. Now here x1 y1 will be this point, and here this is our x2 and this will be our y2. Okay, so again y2 minus y1, y2 is here 0, and here y1 is f of a, so that means 0 minus f of a, x2, that is our x2 is here x, and x1 is here a. So finally now what we'll do, we'll just simplify this relation and we'll get our final formula. 0 minus f of a, that will be minus of f of a divided by x minus a. Okay, now we just simply do the cross multiplication, nothing, just simply do the cross multiplication. Take this term to this side, that means x minus a, and this f of a, f of b minus f of b to this side, that means minus f of a by f of b minus f of a, just interchanging by cross multiplication, and with that step this b minus a, which is in the denominator, takes to that side numerator, that means it will comes in the form of multiplication. Clear? After that, this minus a, if this minus a from this side goes to that side, it will become plus a, that is plus a minus f of a by f of b minus f of a into b minus a. Now we will take a simple LCM and we will simplify that. That is taking the LCM, f of b minus f of a. LCM, just what is the here in the denominator 1, and here f of b minus f of a, so their LCM will be f of b minus f of a. Now just doing the cross multiplication, a into f of b minus f of a minus, and this side will remain unchanged, that is f of a into b minus a. Clear? Now we just simply, after multiplying, adding, subtracting, we will get, finally formula will be as a into f of b minus b into f of a by f of b minus f of a. This will be the required formula. What will be the formula? A into f of b minus b into f of a by f of b minus f of a. Just remember this. This is the final formula of Regula Falsi method. This method is also known as method of false position. Don't worry, I will provide the handwritten notes. The PDF will be there. Just see that PDF. So this is the formula of Regula Falsi method. Okay, now what we have to do, we have to first of all, now this is a formula. Now we'll learn what is the working scheme. That means working scheme, I mean to say, what is the working rule to solve the numerical problems. Okay, so let's start with the working rule. So this is all about the introduction to the formula. Now we'll learn what is the working rule of this method. Now the working rule. So for the working rule, the step 1, the initial step, we know that first of all what we have to do, we have to find that interval where the root lies. And we all know how to find that interval. We have to find an interval a0 b0. a0 b0, why I am saying that? Because initially we'll name that a0 b0 with the condition that f of a0 into f of b0 should be less than 0 by this particular condition. We know that first of all we will find f of a0, then we will find f of b0, and the product result will be less than 0. Then we will get that the root lies between a0 and b0. So this is the input. Now then we have to draw a table. Now what is the procedure of drawing the table? First of all we denote n. N means the number of steps, the number of iteration. an and bn. Now an and bn. Now for suppose we have, when you are finding f of a0, if you consider f of a0 is less than 0, that means it is negative. So we will denote an as minus sign. And f of b0 is your positive. If this is suppose, if f of a0 is negative, then we assigned an as negative, and f of b0 is positive, we assign bn as positive. Depending on the sign of f of a0 and f of b0, we will assign the sign an as negative, bn as positive, or the opposite one also, vice versa. So then the next thing what we have to find, we have to find f of an. That is, at which point an, we have to find function value at that particular point. Then we have to find f of bn. Same, using this bn we will find the function value at that particular point. And the most important, we have to find this, similar like the bisection method table, xn plus 1. And now xn plus 1 will be the same formula. What was the formula of our Regula Falsi? If you remember the formula, a f of b minus b f of a by f of b minus f of a. Now using the same formula, just giving the subscript as n. an f of bn. See, I'm writing the same formula, just giving the subscript n. bn f of an by f of bn minus f of an. Just writing the same formula but by giving the subscript n. So then we have to find xn plus 1, and last, the finally, which is the most important, we have to find the function f of xn plus 1. Now what we'll do basically, suppose for this 0 step we will find this one. I'm writing for example, and suppose we get a values, an value is 0, bn value is 1. For that particular function we get some value here, some value here, function value, and putting all these 4 values in this xn plus 1, we will get a particular value here. Okay, then we will find f of xn plus 1. That means finding the function value at the particular point xn plus 1, and that value is positive. Suppose that value comes positive. So again, using that bisection method, what we will do in the bisection, if it is positive, we will put the next bn, the bn will be changed by this xn plus 1 in the next step, and this an will be remain same, and this bn will be changed by xn plus 1. Why? Because this f of xn comes positive, and as bn is positive. And if suppose this bn will be negative, then this xn will be going to be changed by an, because this value comes negative and an is a column of negative. Simple rule. And in this way we will proceed. Now up to which step will we proceed? See, xn plus 1 is our required answer, or we can say required root, until and unless will we get the same numbers. Suppose the question is about 3 decimal places, so we have to check after point the 3 decimals. Until and unless the 3 decimals are same, we will proceed, and whenever we get the step that the 3 decimal numbers are being same, so we will stop there. So this is the working rule of Regula Falsi method. Clear, students? Now we try to solve one numerical basis of the Regula Falsi method. Okay, so the new question is, using Regula Falsi method, find a root of x cube plus 2x minus 2 equals to 0. Correct up to 3 significant figure. 3 significant figure means total number of digits will be 3. Okay, so what is the function here? x cube plus 2x minus 2. So first of all, initially what we have to find? We have to find the interval where the root lies. Okay, so let's check. First of all, let us find f of 0. That means in place of x putting 0. So after putting 0, we will get here 2. That means 0 cube 0, 2 into 0, 0. That is minus 2. And f of 1, after putting f of 1, that means in place of x just putting 1, we will get here 1. So which implies f of 0 into f of 1 is less than 0. That means root lies between 0 and 1. Okay, root lies between 0 and 1. So this is our initially a0, this is our initially b0. Clear? So now we got the interval where the root lies. The root lies between 0 and 1. Now we'll construct a table and we'll try to solve them. Okay, so here the table I have drawn, and that is just like a working scheme. N, an, then bn, then f of an, then f of bn, then xn plus 1 by the same formula, an f of bn minus bn f of an divided by f of bn minus f of an, and last f of xn plus 1. Now the first thing you have to remember, what was f of 0 value? F of 0 value was negative, and I said that 0 will indicate a0. So a0, this one, and f of 0 value was negative, so that's why we assign an as negative, and f of 1 value was 1, that is positive, so we will indicate bn as positive. The most important thing. Let's start with the 0 number step. a0, the interval 0, and bn was 1, the initially 0 and 1. Then f of 0, first of all we have to find f of 0, that means the functional value at an, that is f of 0. What the value was? Minus 2. Then we have to find f of bn. F of bn means bn is 1, and is f of 1, the value is 1. And then we have to find xn plus 1. So let's do the calculation. First step, we have to find xn plus 1. A formula an, starting from an. What was an? 0. So 0 into f of bn. F of bn is 1 minus bn. Bn is here 1. F of an. F of an is here. F of an, this one, minus 2. Then f of bn 1 minus f of an minus 2. That means 0 into 1 0, minus minus plus 2, and here 1 minus minus plus, that means 1 plus 2 3, and 2 by 3 is 0.67. So we will put 0.67. Then we have to find the functional value, that means f of 0.67. 0.67, you will find this value. Okay, and after that you will find that this value is nothing but minus 0.36, which is less than 0, a negative number. Okay, so this is the step 1. So now we will going to start the step 2. Now what is the value here? Negative. Now the point that comes here, the negative. That means now for the second table we will use this xn value in the negative column. What was the negative column? An was the negative column. So we will use this point in here, 0.67, and bn will remain as same. Now again we have to find the functional value. Functional value, that means f of 0.67, and that value is minus 0.36. Okay, and again the functional value, this will be same, f of 1, that is 1. This will remain same. Then again we have to find xn plus 1. Now for the second step calculation, xn plus 1, an, what was the an? 0.67 into f of bn. What is f of bn? 1 minus bn is 1 into f of an is minus 0.36 divided by f of bn was 1 minus f of n, that is minus 0.36. so here 0.67 into 1 is 0.67, minus plus, that is 0.36, and here 1 minus plus 0.36. if you add and divide, you will get 0.757. so that is the xn value for the second step. That means we will write here 0.757, and again we have to find the functional value, that is 0.757, and we will get that minus 0.0522, which is again negative. Minus, now again negative, that means for the step 2, now for the step 2, see again the negative value. That means now the again xn plus 1 will, this xn plus 1 value comes in the negative column. Why negative column? Because the function value gives negative, so this comes under the negative column, 0.757, and again this is bn will remain same. Again we have to find the function value, 0.757, and that value will be your minus 0.052, and again f of bn will same 1, and again we have to calculate the xn plus 1 in the same way, and we will get that. I'm just writing directly, you will calculate that 0.769, and for that again we have to find the functional value 0.769, and again we will get as minus 0.00724, and which is again negative. So in this way again we will do for step 3, step 4 and step 5, and up to this, when we, until and unless we will get the 3 significant figure as same. So this question you will try, or I have already done this question and I will provide you with a handwritten note. I just do just to explain how the problem is to be solved. So just see that and just try to solve some more questions. I have also given some more questions on this particular topic, regular falsi. Just try to solve that also, and just also see the solution of this particular question also, because this is not, until this is still incomplete. I didn't complete this one. I just explained the procedure how to solve the question. I didn't solve the question fully. The full questions solution is provided, will be provided in your PDF format. Just check that once. And up to this is for today. This is a regular falsi. We have, in this video we have completed the introduction to the formula, the working scheme, the way to solve the numericals. And if you have any doubt regarding any explanation or any step, let me know. I will try to solve that also. And some homeworks are there, try to do that homeworks. So for today, up to this only. Thank you for listening. Thank you so much. And next we meet with another new video on another new topic. Until then, stay home, stay safe, Goodbye.